Hello, my name is Duke and currently recording. This trouble session is Adrian. We are 2-point trouble. We solve problems. Okay, so what do you see on the board right is what appears to be a quadrilateral. No, it is a quadrilateral, okay? So basically, you might have never seen a quadrilateral ever since grade school, right? Depending on how long you've been out of school. But here's one interesting thing that you might want to know about a quadrilateral. Basically, if I were to draw out a line, right, from the midpoints, right, to any point within the quadrilateral. See, I'm going to go ahead and refresh you guys what a midpoint is if you've never experienced it before. If you never heard what a midpoint is, do not worry about it. I'll explain to you what a midpoint is, okay? So, basically, the assertion is that basically that the area of this quadrilateral or triangle plus the area of this quadrilateral or triangle, right, is equal to half the area. See, the opposite quadrilaterals or triangles will always add up to half the area if you were to draw a line from the midpoints of the quadrilateral, right, from each line to a point within the quadrilateral. It can be any point, and it can be any quadrilateral, by the way. So this is, it's not a special case, it's a general case. All right, so what is a midpoint? A midpoint basically is a line, right, that cuts a line in half. See, so these are equidistant from this point. Equidistant meaning that they are equal in distance. All right, so what this implies that the line of BX is equal to CX, right? Same thing we can say for the other lines as well. So how do we go about showing from this case, right, that the area of this quadrilateral plus this quadrilateral, right, is equal to half the area? Let's find out. So basically, if we were to have the congruent triangle, right, and if we were to just place one of the sides of the triangle, right, up against one another, this would create a parallelogram, as you can see. These two triangles, right, they are congruent. Okay, congruent meaning that they're basically the same shape and same size. All right, so how do we know that this implies that this is half the area, right? The triangle is half the area of the parallelogram. Well, we have two triangles, and we just added another triangle in, right? So, by logic, you can see that the area of just the triangle itself, right, is just half of this parallelogram. Now, how do we know that the area of the parallelogram is base times height? Let's go ahead and find out, okay? So over here, right, we now have the altitude, which is h, right? H meaning the height of it, right? And we just took half of this triangle, right, and moved it over here. See? Now, because the size of the base is conserved, right, when we do that move, right, we now have a rectangle. We all know what the area of a rectangle is. It's just the base times height. And by deduction, right, now that we know what the area of the parallelogram is, base times height, because it's half the area of the parallelogram, the area of the triangle is just half the base times height. Yeah. You may know Euclid. Well, basically, I would consider him to be the father of mathematics, right? Because he developed mathematics in many different sorts of fields, not just geometry. If you were really interested in knowing more about Euclid, right, go ahead and Google him. But let me go ahead and show you one of the most important consequences of his 5 postulates. His first postulate, Euclid's first postulate, right, basically is that if you were to put 2 points, right, on a flat surface, then you can basically draw a straight line towards them, right? You can basically draw a straight line. See? Straight line meaning that there exists a line segment. See? Line segment meaning there's like, if you were to have like a line, right, that stretches out forever, and if you were to just cut the line, right, you would have a line segment as such. All right, so as I explained earlier, right, the midpoint is just a point on the segment, right, that divides both of these lengths, right, into half of the total length PQ. What this entails is that PR is equal to RQ. This is very important into understanding the consequence of having the area issue that we're currently having with the other quadrilateral.
If you take any triangle, say PYQ, and you take a midpoint of any side, say the midpoint of P and Q, and you call that point R, and you combine, or you draw a line from Y to R, from the midpoint to the vertex, then the area of triangle PYR and triangle RYQ will be equal, and they will be referred to as K1 and K2 respectively.
There we go.
Okay, we know this because the area of a triangle is base times height. And we know that if the original triangle PY and Q, we can drop an altitude from Y to the opposite side PQ, and this will be the height. And so the base of the triangle PRY is PR, the base of the triangle RYQ is RQ, and these bases are equal. And so the height of both triangles is going to be equal to this altitude. So if the bases are equal and the altitude's the same, then the area of each, which is equal to 1/2 times base times height, will be equal. Okay, now that we understand all of that, let's prove this. And as you may notice, this is a different quadrilateral, but this holds true for all quadrilaterals. So, with the very last thing proved that with triangles, let's draw some triangles in here by combining all of the vertexes with the midpoint, or with the point P1 that's in the interior of the quadrilateral. This creates several triangles. This is helpful because we know that each of these triangles, BC and P, each of these triangles is going to have the same altitude from each side. Because of this, that means the triangle CYP, triangle YPD are going to have equal areas. Call them K1, K2. The triangle DPZ will be equal to the area of triangle PZA. Call the areas K3, K4. PAW equal to PWB. Call this K5, K6, and CPX and XPB. Call them K7 and K8, which means the total area of the triangle will equal to the summation of all of these interior triangles. But because 1 and 2 are equal, 3 and 4 are equal, 5 and 6 are equal, and 7 or 8 are equal, this can be rewritten as K1 plus K1 plus K4 plus K4 plus K5 plus K5 and plus K8 plus K8, which is equal to 2 times K1 plus K4 plus K5 plus K8, which is equal to the area of this quadrilateral, K1 plus K8 in the area of this quadrilateral, K4 plus K5, which is equal to half of the original area. And then this is also true for K1 plus K3 and K6 plus K7.